All right, now we're looking at some applications of trig, or some trig word problems. A couple things that we need to go over that we haven't looked at before is something called the angle of elevation and the angle of depression. So the angle of elevation would be something that you're looking up to. So if there was somebody standing here and you looked up maybe towards the sun, this is the angle of elevation. You're lifting your head up and you're looking up at something. Angle of depression would be when you're looking down. So it doesn't really make sense if you're kind of standing on ground. Usually it's more like you're in the air. So you're maybe you're in an airplane and you're looking down. And if you're looking down, it's not this angle. So say you're straight up and down. It's not this angle. You're looking down. Normally you're looking forward, but now you're looking down, and it's that space in between. That's called the angle of depression. So it always starts with a horizontal line, and then you look down, and this is the angle of depression. So we're going to have a couple of examples of each of those here. But let's take a look, before we get into that, at the first example. It says, a kite is tethered to the ground with 10 meters of string. The string makes an angle of 60 degrees with the ground. We want to know how high the kite is. So usually it's kind of helpful to draw something. So you've got maybe a kite here, and it's staked down to the ground. So we got the ground there. And it says with the ground, it makes an angle of 60 degrees. So this, I believe, is 60. Yeah, so 60 degrees. So we want to make this angle 60 degrees. And then we want to know, well, how high is this kite? So it makes a 90 degrees, so we can use our SOHCAHTOA. And we want to know, what is this? I'll call this X for now. So because I have my perspective of 60 degrees, I can label this. So this is my opposite, because it's directly opposite the angle, or my perspective. This is my adjacent, and the hypotenuse is always on the opposite of the 90 degrees. And so it looks like I think I've got some information, 10 meters of string. So it says that this string is 10 meters. Therefore, I have the opposite that I need to find, but I also have some given information, which is the hypotenuse. That is O and H. So I'm going to use SO as my formula. Okay, so let's see here. So the formula, sine of some angle, theta, equals O over H, so op over hype. And now I can fill in the two things that I know. So sine of 60 degrees. So theta is given at 60 degrees. The op is just an X. I don't know it yet. And it's right there. And the hype is 10. So I'll put 10. So sine of 60 here, we're actually going to have to go and take a look. So sine is up here, in our first column. And so sine, cosine, tangent. Okay, so now I got to go 60. So I'm going to be coming down here, 59. What is sine of 60? 0.866. So I'm going to go 0.866 equals x over 10. Now I got to get this x alone. So I'm going to times it by 10 to get rid of that 10, and times by 10. And when you times by 10, all you need to do is just move with 1 0. 10 has 1 0. We're going to move the decimal place over once. So it looks like our answer is, instead of 0.866, I move it over to 8.66 equals x. Now it is a word problem. It's an application, so we need to put it into a sentence. So you can write a sentence like, the height of the kite is 8.66 meters. I'm going to write that later, but you need to have some sort of sentence to tell the reader what the answer is.
Mother loves me.
I love mother.
So here's a sentence. The height of the kite is 8.66 meters. So let's take a look at the next one. So we have a 280 meter tower That's how tall it is. It's a few blocks away from a student. The angle of elevation, remember that's looking up, to the tower, to the top of the tower is 35 degrees when viewed by the student. How far away is the tower? So we're going to have to draw this tower, and we're going to draw a student looking up. So that's what I've done here. I've got this tower, and I have a student looking up. So it's the angle of elevation is 35 degrees, and we know that this is 280. And we want to know how far away the student is from the building, from the base of the building. So, let's see here, we've got to label. We have a perspective, so this is always the height because it's opposite the 90 degrees. This is opposite our perspective, and this is the adjacent. So it looks like we're trying to find our adjacent, and we're given the opposite. So there's that, and we're given the opposite of 280. So A and O, that's going to be TOA. So tan of the angle theta equals opposite over adjacent. So tan of 35 degrees equals 280 over the adjacent, I believe, yep, is x. So now we need tan of 35. So where's 35 here? Tan is 0.700. So 0.700 equals 280 over x. Now I don't want the x on the bottom. We've done this before. I'm going to move this x up top. I can do that by multiplying. I actually don't need these extra zeros, so we have a 0.7x equals 280. These x's here have been eliminated, and x times 0.7 is just a 0.7x. Now I can get rid of the 0.7 by dividing. So I just have x equals whatever this is. And it looks somewhat intimidating because you're dividing by a decimal. But what I'm going to do is I'm going to move this over once to make it a 7. And I can't do that without also doing that to the top. So I'm going to move that over. So I have 280 plus an additional 0 from moving the decimal over 7. And so now I know that 28 divided by 7 would just be 4. And there's 2 zeros. So the answer is 400. And I believe this is in meters. So again, we're going to have to write a sentence saying the student is 400 meters away. And then we can box that and we are done. I think it's meters. I should just double check. Is it meters or is it feet? Yeah, meters. Okay, let's take a look at this one. We have a flagpole that's 20 feet high. And it casts a shadow that's 5 feet. Okay, I just want to draw that before I do anything. So I got a flagpole. And I know it's 20 feet high. So I'm going to write that. 20 feet. And it casts a shadow. But the shadow's only 5. So the shadow's going to be kind of down here. And it is 5 feet. I'm assuming we're going to have some sort of triangle here. It looks like we're going to have this 90 degree. So let's see what it's asking for. What is the angle of elevation to the sun? So the shadow is obviously created from the sun. The sun's hitting the flagpole and creating the shadow. And it's about looking up. So we've got this looking up here. And we don't know what that angle is. So that's unknown. But we can label. We've got this as opposite. This one, opposite the 90 degrees, is the hypotenuse. And of course, this is the adjacent. So it looks like if I circle what I have the adjacent, which is 5, and I have the opposite, which is 20. That is O and A, so that's going to be TOA. So let's write the formula. Tan of theta equals opposite over adjacent of x equals opposite, which is 20 over adjacent, which is 5, which is just a 4. So let's look back here. Where's tan 4? So it looks like 4.001 is the closest, 76. So I'm going to say the angle x is 76. So we'll need to put that into a sentence. So that's right there. The angle of elevation is 76 degrees.